Hiya! So in this video, we're going to be looking at one-to-one change of variables. And one-to-one might sound a little confusing, but it's not too bad. So remember that the main idea, what we're trying to do in this section, is to start with some random variable and convert it to some other random variable, right? Through some formula. We don't know what the formula is, but we have some function, and that's what it is. So we have x is some probability density function f of x on the interval ab, and we want to convert it to some y, where y is some function g of x. And here for this one-to-one, we're going to assume, and here's the strong assumption, where g is strictly increasing or decreasing on the interval ab. This is a strong assumption. So everything in this little part we can't do unless we have this condition. So please note this. So notice how we the range part isn't too bad, right? The range part from the previous video, you should remember the range is just applying the x range into the function and you get the y range. And that's basically what we have. It's going to be either g of a of g and then g of b, or g of b first and then g of a. So this is the kind of two ways we can view this, right? So the main thing is really calculating our f sub y of y and stuff like that. So basically what we have is, well, if we state these two are the same, right? If we say they're identical, they're one-to-one, this is where the idea of one-to-one comes from, then we should get some formula like this. And this only works because they're both increasing. So let's kind of use an example and kind of see where this comes from, or like how this works. So here we're going to assume we have x has exponential density. So f sub x is equal to e to the minus x. So here lambda is equal to 1. So lambda equal 1. And here we're assuming x is greater than 0, right? So this is our range. So x range is equal to 0 to infinity. How about y? So y, we have that it's equal to the square root of x. So the first thing we need to do is range. So first, range. And for this, we just have to plug in. So we just take square root of 0 and square root of infinity. Square root of 0, this is just going to give us 0. Square root of infinity, well, that's just infinity as well. So really, we have 0 to infinity. So the range doesn't change. Super nice. Second, we're going to try to solve, so we have this thing. So we're going to try to solve for dy dx. So let's solve for dy dx. So here we have y is equal to square root of x. And you can kind of do it one of two ways. You can either take the derivative here, or you can notice that we have y squared is equal to x and take the derivative here. For me, this way is kind of easier because I see right away that this is 2y dy is equal to dx. But you can kind of get the same thing here. Either of these are the same thing, right? So I have dy is equal to 1/2 square root of x dx. Here, notice that y is equal to dx, so, or square root of x, so this square root of x we can convert into a y. But since we need this formula dy over dx, what we'll do is we'll convert this, we'll keep this kind of thing. Both of these should give us the same thing. They all are equal to each other. We get dy over dx is equal to 1 over 2y. And we'll keep this y because this is really what we're trying to solve. So what we have is fy of y. This is equal to, remember, fx of x divided by the absolute value of dy over dx. Here we just plug this in, dy dx, we have this. So we have f sub x of x over dy over dx. Now this f of x, this is just e to the minus x, yeah? Oops, I forgot to plug in. 1 over 2y. So technically 2y, this is positive, so we can just do that. Right, because y is always positive. So we know we don't need the absolute values. And then e to the minus x, well, what is x? X is y squared. So we'll use this for the next equality, which will give us e to the minus y squared 1 over 2y, Well, if you do the multiplication, this will just give you 2y. So we end up getting 2y e to the minus y squared. And that is the density function for this, for y. So it's not too bad. So let's actually look at another example, another quick example to kind of see another way of doing this. Actually, no, we'll pause the recording since cars are honking at me. And we'll look at the next example in the next video. So we kind of break it up into two. So I will see you in the next video for the next example. See you then.